Variability in both time and space is an inherent feature of climate, as the atmosphere is always in the state of turmoil and instability, leading to variations in weather and climatic conditions. The climate change, thus, is defined as the variations and shifts in weather conditions over space and time of different scales and magnitude, resulting into change of climatic type. For example, from warm and moist climate to warm and dry climate, from warm and moist climate to cool and moist climate, etc. In fact, climate change refers to drastic or secular changes in heat balance of the Earth atmospheric system, moisture, cloudiness and precipitation caused by either external factors such as variations in the orbital characteristics of the Earth, solar variability, that is the fluctuations in radiation from the photosphere of the sun, tectonic processes, mainly the plate tectonics and displacement of the continents and ocean basins, volcanicity, changes in atmospheric composition in terms of concentration of the atmospheric aerosols and carbon dioxide contents, etc., or by internal factors such as exchanges of energy between the atmosphere, hydrosphere, lithosphere and cryosphere, being the ice covered surfaces of both lithosphere and hydrosphere, or by both at local, regional and global levels. The climatochronology, which is the history of paleoclimates, reveals the fact that climates have changed in the geological past, and hence it is opined that the world's climates have changed in the past, are changing now, and there is every reason to expect that they will change in the future. If the change is law of the nature, the change in climates is a reality, because the climate of a region is not fixed and static, rather it goes on changing. Sometimes the changes are cyclic and rhythmic. Such changes is called the climatic cycle. The example of occurrences of ice ages during the Precambrian period, which is from 850 to 600 million years before the present, and the Ordovician period, which is from 450 to 430 million years before the present, or the Carboniferous and the Permian periods, which are 300 million years before the present, and Pleistocene period, which is 2 to 3 million years before the present, validates the concept of cyclic nature of climatic changes. After the lesson, you will be able to understand the concept of climate change, the scale dimensions, the climatic changes indicators, the climatic changes during the present era, and the causes of the climate change. The climate changes are supposed to be quick and rapid rather than slow and gradual. But this may not be always true, as climate changes both gradually and rapidly, partly and drastically. For example, the climatic change which occurred during the Jurassic period, leading to mass extinction of the dinosaurs due to the sudden onset of the cold climate, was rapid and instantaneous. In fact, the rate of the climate changes depends on the nature of the causal factors. The rapid Jurassic climate change is related to sudden collision of the Earth and a giant meteors and consequent release of enormous amount of dust in the atmosphere. One cannot infer the nature of long period climate on the basis of present day climatic conditions. It is also an observed fact that the cool periods of the Earth's history are periods of greater than normal climatic instability. The human society with present day weather conditions is seized with the problems of possible climatic changes in near future. The most significant global environmental problem faced by the world community is global environmental changes leading to probable climate changes consequent upon global warming, resulting from a host of causal factors, namely the ozone depletion, increase in the emission of the greenhouse gases at alarming rates, deforestation, etc. The probable net result of the global warming would be climatic changes at local, regional and global levels. The international communities are scared of catastrophic adverse effects of future climatic changes on different spheres of man and nature. For example, deglaciation and sea level changes, submergence of island nations and major coastal lowlands, atmospheric dynamics including evaporation and precipitation, global radiation, balance, photosynthesis and ecological productivity, plant and animal communities, human health and many more. It may be summarized that climate change is a reality. It has changed in the past, it is changing at the present, and it will change in the future. The change of climate may be slow and gradual, rapid and catastrophic, periodic, semi-periodic or non-periodic, short-term or long-term, may be at local, regional and global scales. It may be due to natural factors or anthropogenic factors. It is thus necessary to discuss various aspects of climate changes, namely the scales of the climate changes, both spatial and temporal scales, indicators of the climatic changes, that is the evidences of climate changes, reconstruction of the paleoclimates, that is the climatochronology, climochronology, causes of climatic changes, theories of climatic changes and effects of climatic change on both nature and biological communities, including the human beings. The climatic variations and changes are viewed in terms of temporal and spatial scales depending on the purpose of the studies. The temporal scales of the climatic changes range from a very micro scale involving 10-day period to macro temporal scale involving thousands to millions of years. The variability may be periodic, that is quasi-periodic or non-periodic, or alternatively it may show a progressive trend. It may be mentioned that spatial and temporal scales of climatic changes are correlated. For example, as the temporal scale of change becomes shorter, the area also becomes smaller. Generally, climatic changes are considered at two levels: short-term changes and long-term changes. Short-term climatic changes involve the consideration of changes in the energy balance of the Earth atmosphere system, leading to periodic changes in weather and climate. This temporal scale involves time span ranging from few years to thousands of years. Short-term climatic changes are either interannual or they may persist for many years and are generally caused by anthropogenic factors. On the other hand, long-term climatic changes persist for thousands to millions of years and are exceedingly slow. These are always caused by natural factors. The evidences of climatic changes in the past, which are utilized in the reconstruction of climochronology, which is the history of paleoclimates, are called the indicators of past climatic changes. The riddle of reconstruction of the paleoclimates is a fascinating puzzle, the solution of which basically depends on the proxy data, which include alternative sources of data as substitutes for real data and logical deductions by the investigators. It may be mentioned that recorded data of weather and climate are available only since Industrial Revolution, more precisely for the last 100 years or so, and hence proxy data for the recorded data are the only indicators to decipher the pages of past climatic history and changes on the basis of Huttonian theory of uniformaticism, postulated by the Scottish geographer, geologist James Hutton in the year 1785. This theory was based on two concepts of Hutton, namely present is the key to the past and no vestige of the beginning, no prospect of an end. The principle of uniformaticism states that the same physical processes and laws that operate today operated throughout the geological time, although not necessarily always with the same intensity as now. But Hutton postulated same intensity of processes throughout the geological time. The indicators of paleoclimates are to be classified on the basis of basic sources. There are many climatic change indicators, namely biological indicators, within which we have floral indicators, being fossil remains of the plants, fossilized pollens, oxygen isotopes, tree ring growth. And then we have the faunal indicators, which include fossilized animal remains, distribution and dispersals of the animal remains. Geological indicators, which include terragenous ancient deposits, which further include the lacustrine deposits, the evaporated deposits, the sedimentary deposits, and then we have the marine deposits, which include the seafloor deposits. Then we have the pedogenic indicators. Next, we have the cryogenic indicators, which further include the glaciation, which further comprise of ice ages, glaciers and glaciation, ice sheets and ice cores, and then we have the periglacial evidences. The next indicators are the tectonic indicators, which include the plate tectonics, which further includes pole wandering and continental drift, paleomagnetism and seafloor spreading. Then we have the sea level changes. The next indicators are the geomorphological indicators, which include morphological features, which further include erratics, sand dunes, river terraces, duicrusts, pediments, tors, and then the further indicators are geomorphological processes. And the last indicators being the historical records, which include flood records, drought records, migration of man and animals. Climochronology may be defined as systematic description of climatic conditions and climate changes in terms of geological history of the earth, that is, the past climates of each period of the earth's history. The reconstruction of the paleoclimates, that is climochronology, means rearranging the climatic history of the globe or part thereof on the basis of indicators or evidences of paleoclimates. The description of the climochronology of the world may be attempted by, firstly, climatic changes during the geological periods, climatic changes during the quaternary period, and climatic changes in the recent past, about 1000 years or so. The geological history of the earth, or the geological clock, refers to the reconstruction of evolutionary sequences of the geological events involving the information of various zones, which include the crust, mantle and the core of the earth, formation and evolution of the geomaterials or the rocks, formation and development of mountains and falls, evolution of different lives, etc. The whole geological history, right from the origin of the earth to its present form, has been divided into major and minor periods on the basis of forms of the life or the organic remains, characteristic rock deposits, places of rock formation, major tectonic events, etc. The whole geological history of the earth has been divided into 5 eras. The largest time division of the earth's history has been termed as the era based on 5 major groups of deposits. Some scientists have put together all the geological events of the past history of the earth in the form of a clock. Thus, the spiral system representing the whole geological and geomorphic history together is called as geological clock, wherein 1 billion years represents each revolution of the clock's arm. Each revolution is further subdivided into hours, where each division, that is the hour, corresponds to 100 million years, and minutes represent the time of 10 million years. The proxy data from the geological and biological sources and indicators, instrumental records, historical records, documentation, etc. provide ample authentic information to reconstruct yearly climatic fluctuations since the 1st century AD. The records show that the temperature and the precipitation conditions of European continent and Mediterranean regions were similar to present day climatic conditions in the 1st century of the Christian era. These areas experienced further more humid conditions characterized by increased precipitation and ameliorating temperature up to mid 4th century AD. Europe and North America experienced dry phase resulting into semi-drought condition in the 5th century AD. The increased aridity caused drying of several lakes in the western United States of America. The climate in the northern hemisphere became further harsh during 600 to 700 AD when climate became warmer and drier. The increased aridity resulted in melting of valley glaciers in the Alps of the Europe and opening of frozen passes allowing free movement of people across the alpine mountains. It may be mentioned that these passes are again in frozen condition at present due to re-establishment of the valley glaciers. The moist addition returned again in the 9th century AD. The period from 950 to 1250 AD, that is 300-year period, is called as the phase of little climatic optimum in the climatic history of the earth, when climate became warm and relatively dry as average temperature increased by 1 degree to 2 degrees Celsius from the present day global average temperature. The climate of Greenland and Iceland became mild and attracted the Vikings from Iceland to settle in the Greenland. It may be mentioned that Vikings migrated from Europe to settle in Iceland in the 9th century AD because of favorable conditions characterized by warmer climate. The climatic conditions in the southern Greenland allowed the growth of stunted vegetation, pasture and agriculture to support newly settled human population. The period from 1250 to 1450 AD was characterized by reversal of mild climate of the 10th to 13th centuries AD, as referred to as temperature being to drop, causing accumulation of more ice over Greenland, drifting of ice sheets and numerous icebergs in the North Atlantic Ocean. The drifting of the icebergs disrupted human physical connection of Greenland with Iceland and Europe. The 13th century saw very stormy weather in the Atlantic Ocean and the North Sea, while extreme arid conditions leading to severe droughts prevail in the western United States of America. The trend of worsening climatic conditions in the middle and high latitudes of northern hemisphere continued, and the climate became further harsh for another period of 400 years, that is from 1450 AD up until 1880 AD. As the temperature fell below the freezing point, giving birth to another glacial period known in the climatic history of the earth as Little Ice Age. The climate of Greenland became so cold that the earlier settled people perished and their settlements and other infrastructure were buried under thick cover of ice sheets. The alpine glaciers became more active. All the glacial valleys were covered with thick ice sheets. The advancing glaciers engulfed several villages at the foothills of the Alps mountain chains. Several lakes and rivers were frozen, which are presently unfrozen, etc. For example, the Thames River of England was frozen 4 times in 16th century, 8 times in 17th century and 6 times in the 18th century. The historical records and Icelandic sagas very much indicate the severity of the climate in Iceland. Extreme cold conditions led to human deaths due to severe famines. It may be mentioned that glacial period, that is the Little Ice Age from 1450 to 1880 AD, was not always characterized by continuous extreme cold conditions and advancing glaciers. Rather, it was punctuated by several cold and warm intervals. It is believed that each cold period continued at least for 30 years in each century. That is between the 15th and 19th centuries, and 2 cold periods were separated by relatively warm period. The coldest period culminated in the year 1816, when major parts of the northern Europe and United States of America did not experience summer season. The year 1816 is known as the year without a summer in the climatic history, when the glaciers became most active after the Pleistocene Ice Age. Thereafter, climate began to improve due to rise in the temperature, and by the end of 19th century, the Ice Age was terminated. The records of global temperatures since Industrial Revolution denote slow but irregular trend of rise of temperature, that is ranging between 0.3 degrees Celsius and 0.6 degrees Celsius. Following R.G. Berry and R.G. Cholly, the phases of rise in the temperatures after 1860 have been identified as follows. The first period being highly irregular trend of rise in the temperatures ranging between 0.2 degrees Celsius to 0.4 degrees Celsius between 1860 to 1920 AD. The second trend, consistent trend of rise of temperature of mean value of 0.4 degrees Celsius between 1921 and 1945. Oscillating trend of the rise of temperature between 1946 and 1975 AD around 0.4 degrees Celsius. The northern hemisphere was warmed while the temperature in the southern hemisphere remained more or less constant, that is, neither increase nor decrease. Overall warming trend continued between 1976 and 1989 AD when temperature registered an upward rise of 0.2 degrees Celsius. The global rise of the temperature reached its peak in the last decade of the 20th century, that is the 1990s. 6 out of 7 warmest years in the record occurred since 1980. It may be summarized that overall increase in the surface air temperature in the 20th century has been about 0.5 degrees Celsius to 0.7 degrees Celsius against an average rate of increase of 0.3 degrees Celsius per 1000 years at the global level. As mentioned earlier, climatic changes are affected by changes in the atmospheric circulation and interactions among 5 components of the Earth, of the atmospheric system, namely the atmosphere, hydrosphere, lithosphere, biosphere and cryosphere, which is the frozen surface of the Earth, wherein the amount of received solar energy and the processes of distribution, redistribution and absorption of solar radiant energy at the Earth's surface are important considerations of the state of climate of an area in specific time period. The causes for such interactions leading to climatic changes are related to outside sources, say the extraterrestrial sources, and inside sources, that is the Earth atmospheric system or the terrestrial sources. The causes and theories of the climatic changes are viewed in terms of periodicity of the climatic changes, which are generally of 2 types, namely short-term climatic changes and long-term climatic changes. Since the nature and patterns of the climatic changes vary temporally, and hence the causes of such changes are also of varied nature. This is why no single theory can explain all types and patterns of the climatic changes, and thus we have a host of causes and theories of the climatic changes. Since the Industrial Revolution, that is 1860 AD, the man's increased economic activities and the application of advanced technologies are introducing significant modifications and changes in the climatic conditions. This has led to the emergence of a new dimension in the climatic changes and an additional source thereof. Thus, the source of the climatic changes may be grouped into the following broad categories: outside sources or the extraterrestrial sources, inside sources or the terrestrial sources, and the anthropogenic sources. The significant causes and related theories of climatic changes may be stated as solar irradiance, that is the variation in the solar radiation, sunspot cycles, astronomical theories, which include the eccentricity of the Earth's orbit, obliquity of the ecliptic, the precession of the equinoxes, and the Earth-Sun relationship. Atmospheric dust hypothesis, mainly the volcanic eruptions and dust thereof, carbon dioxide hypothesis, and the continental drift and pole wandering, tectonic and topographic control theory, oceanic variation hypothesis, extraterrestrial bodies, collision theory, and anthropogenic changes or the changes in the Earth's surface and atmospheric composition. Climate change is one of the most significant environmental challenges facing humankind today. Geography has much to contribute to understanding the complex spatial dimensions of climate change, including the observed and anticipated geographical differentiation in potential